This is a for practice example 6.7 on page 227 of our textbooks. In this example, we rearrange the ideal gas law, PV equals nRT, in order to be able to solve for the density of a gas. So if we rearrange the Pivnert equation, PV equals nRT, we can come up with the equation density, and in this case, density of a gas is reported in grams per liter, is equal to P, pressure, times big M. In this case, big M stands for the molar mass in grams per mole, divided by R, which is our ideal gas constant, and T, which is temperature, needs to be in units of atmospheres. And our pressure needs to be in ATM. So all this is just a rearranged PV equals nRT equation so that if we want to, we can solve for the density of a gas. So the question states to calculate the density of xenon gas at a pressure of 742 millimeters of mercury and 45 degrees Celsius. So they give us a pressure, a temperature. We can figure out the molar mass of xenon gas because they gave it the identity, and we can look at the periodic table to do this. So in the problem, before we start plugging things in, we're going to need to change our millimeters of mercury to atmospheres, and we're going to need to change our Celsius to Kelvin. So our pressure, 742 millimeters of mercury, but we need to convert it. So we're going to divide by 760 millimeters of mercury equals 1 ATM to get a pressure of 0.9763 ATM. Our molar mass, if you consult the periodic table, the molar mass of xenon is 131.29 grams per mole. Our R value, always going to be the same since it's a constant, 0.08206 liters times atmospheres over mole times Kelvin. And then our temperature is 45 degrees Celsius, but it needs to be in Kelvin, so we're going to add 273.15 to get temperature 318.15 K. Now that I have all that, I can plug it into my modified ideal gas law equation to solve for density. This guy right here. So density is equal to pressure, 0.9763 ATM, times molar mass, 131.29 grams per mole, divided by ideal gas constant, 0.08206 liters times atmospheres over mole times Kelvin, and then finally our temperature, 318.15 K. So then we look at our units. Atmospheres cancel, moles cancels, kelvins cancel. Only thing that doesn't cancel is grams per liter, which is what we're reporting our density unit in. So then D is equal to, plug all those numbers in, divide. Our density for this is 4.91 grams per liter, because those are the only two units that didn't cancel. So the density of xenon under these conditions is 4.91 grams per liter. And that's how to utilize a variation of the ideal gas law to solve for density of a gas.